Hey everyone, welcome back to the networking series. In today's video, we're talking about switching protocols, which are essential for directing data within local area networks or LANs. Switching protocols determine how data packets are forwarded between devices in a network, ensuring smooth communication and optimized traffic flow. By the end of this video, you'll understand the key switching protocols and how they impact the network performance. Let's jump in. First, what exactly is a switching protocol? In networking, a switch is a device that connects multiple devices on a LAN or local area network and forwards data packets between them. A switching protocol is the set of rules that determines how the switch handles these packets, ensuring that the data reaches the correct destination. Switching protocols are responsible for packet forwarding and ensuring that data moves efficiently within the network. The most commonly used switching protocol is Ethernet, which operates on the data link layer of the OSI model. Let's start with Ethernet switching. Ethernet is the dominant protocol used in wired local area networks, and it defines how data is transmitted over cable. Switches operating on the Ethernet protocol forward data between devices based on MAC addresses. When a data packet is sent, the switch reads the destination MAC address and forwards the packet to that correct device within the network. Switches maintain a MAC address table, which stores the MAC addresses of all connected devices and the corresponding switch port each device is connected to. This allows the switch to know exactly where to send the data, making communication between devices faster and more efficient. Now, let's talk about layer 2 switching. In a traditional Ethernet network, switches operate at layer 2 of the OSI model, also known as the data link layer. At this layer, switches forward packets based on MAC addresses and handle intra-network communication, meaning the devices are all part of the same local network. However, when devices on different subnets need to communicate, we need layer 3 switching. Layer 3 switches, also known as multi-layer switches, operate at both the data link layer and the network layer of the OSI model. They can forward data based on both MAC address, layer 2, and IP addresses, layer 3. This allows layer 3 switches to handle inter-VLAN routing, where devices in different VLANs or subnets can communicate through the switch. Another important switching concept is VLAN tagging. When multiple VLANs are configured on a switch, data packets need to be tagged with the appropriate VLAN ID to ensure they are forwarded to the correct VLAN. 802.1q is the standard protocol used for VLAN tagging, allowing data to be properly routed between VLANs while maintaining traffic separation. Let's not forget about Spanning Tree Protocol, STP, another critical protocol used in Ethernet switching. STP prevents switching loops, which can occur when there are multiple paths between switches in a network. A loop in the network can cause broadcast storms and bring the entire network down. Been there. STP solves this by creating a loop-free logical topology, ensuring that only one path is active at any given time, while keeping other paths on standby in case of failure. Spanning tree's role in network stability is vital, especially in larger networks where multiple switches are interconnected. Without it, redundant links could create loops, which would flood the network with duplicate packets and lead to severe performance issues. Rapid Spanning Tree Protocol, or RSTP, is an improved version of Spanning Tree Protocol, designed to react faster to changes in network topology. If a link fails, Rapid Spanning Tree can quickly activate backup paths, reducing downtime and minimizing network disruptions. Now, let's talk about Link Aggregation Control Protocol, or LACP. LACP is used to combine multiple physical links between switches into a single logical link. This process is sometimes known as link aggregation or port trunking. By bundling several links together, you can increase bandwidth and provide redundancy, so if one link fails, the others can continue to carry traffic without interruption. Another protocol that plays a significant role in switching is IGMP Snooping. Internet Group Management Protocol, or IGMP, is used for managing multicast traffic, which is the transmission of data to multiple devices simultaneously. IGMP snooping helps switches manage multicast traffic more efficiently by only forwarding multicast packets to the devices that have requested them, reducing unnecessary traffic on the network. Switching protocols also involve managing traffic flow to ensure smooth communication. Quality of service, or QoS, is a feature used in switches to prioritize certain types of traffic, like voice or video, over less important data. By enabling QoS, you can ensure that critical applications get the bandwidth they need, even during times of network congestion. Lastly, let's mention Power over Ethernet, or PoE, which is a protocol that allows switches to deliver power to devices like IP phones, wireless access points, and cameras through the same Ethernet cable used for data transmission. PoE simplifies network setup by eliminating the need for separate power cables and outlets, making it easier to deploy devices in places where power outlets are not readily available. So, to recap, switching protocols control how data is forwarded within a local area network. Ethernet switching is the most common type, using MAC addresses to direct traffic between devices. Layer 2 switches handle intra network communication, while Layer 3 switches manage inter VLAN routing. Protocols like STP, RSTP, LACP, and IGMP snooping help ensure network stability, redundancy, and efficient traffic management. Thank you all for watching. Don't forget to like, comment, and subscribe. I really appreciate the support. The channel's nothing without you guys. I'll see you all in the next video. Take care.